Introduction to tectonic plate movements. Title: Introduction to tectonic plate movements. Introduction. The Earth's surface is a dynamic place, constantly changing and evolving. One of the most fascinating processes that have shaped our planet over millions of years is the movement of tectonic plates. These massive shifting plates are responsible for a variety of geological phenomena, including earthquakes, volcanic activity, and the creation of mountains. In this article, we will delve into the world of tectonic plate movements, examining the different types of plate boundaries, the forces behind plate movement, and the resulting geological features. Understanding tectonic plates. Tectonic plates are large sections of the Earth's lithosphere, which is composed of the crust and the uppermost part of the mantle. These plates float on the semi-fluid asthenosphere beneath them. Earth's surface is divided into 7 major tectonic plates, including the Pacific Plate, North American Plate, Eurasian Plate, and African Plate, among others. Additionally, there are several small plates and microplates scattered across the globe. Types of plate boundaries. Tectonic plate movements occur primarily along 3 types of plate boundaries: convergent, divergent, and transform. Each type of boundary is characterized by different interactions between the plate. 1. Convergent boundaries. Convergent boundaries occur when 2 plates collide. There are 3 subtypes of convergent boundaries: oceanic-oceanic, oceanic-continental, and continental-continental. Oceanic-oceanic convergence. When 2 oceanic plates collide, the denser plate subducts beneath the other, creating a subduction zone. This process results in the formation of deep-sea trenches and volcanic island arcs, such as the Japan Islands. Oceanic-continental convergence. When an oceanic plate converges with a continental plate, the denser oceanic plate subducts beneath the continental plate. This subduction often gives rise to coas. Tall mountain ranges, like the Andes in South America. Continental-continental convergence. When 2 continental plates collide, neither plate can easily subduct due to their similar densities. The intense pressure results in the folding and uplift of rocks, forming large mountain ranges like the Himalayas. 2. Divergent boundaries. Divergent boundaries are characterized by the separation of 2 plates, leading to the upwelling of magma and the creation of new crust. This process occurs primarily along mid-oceanic ridges, where new oceanic lithosphere is formed. The Mid-Atlantic Ridge is a prominent example of a divergent boundary. 3. Transform boundaries. Transform boundaries occur when 2 plates slide past each other horizontally. These types of boundaries are known for their high-frequency earthquakes. The San Andreas Fault in California, USA, is a famous example of a transform boundary. Forces behind tectonic plate movement. 3 main forces are responsible for driving tectonic plate movements. 1. Mantle convection. The asthenosphere, a semi-fluid region below the lithosphere, is subjected to convection currents. These currents cause the plates to move as they carry the plate's weight. 2. Ridge push. At mid-oceanic ridges, where new crust is formed, the elevated lithosphere exerts a gravitational push on the plates, propelling them away from the ridge axis. 3. Slab pull. Subduction zones generate a gravitational pull on the subducting plate as it sinks into the mantle. This pull contributes to the overall motion of the tectonic plates. Geological features. The movement of tectonic plates gives rise to various geological features, each with its unique characteristics. 1. Earthquakes. As plates interact and release the accumulated stress along plate boundaries, earthquakes occur. The severity and frequency of earthquakes depend on the types of plate boundaries involved. 2. Volcanic activity. Plate boundaries are often associated with volcanic activity. Subduction zones, where one plate moves beneath another, are known for their explosive volcano eruptions. Diverge. End boundaries. Volcanic activity appears mainly in the form of fissures and lava flows. 3. Mountain formation. Collisions between tectonic plates can result in the formation of mountain ranges. These can range from fold mountains, where rocks buckle and fold due to compression, to block mountains, which are created when large blocks of crust are uplifted. Plate tectonics is a scientific theory that explains how the Earth's lithosphere, which consists of rigid tectonic plates, moves and interacts with one another. This theory has revolutionized our understanding of the Earth's geological processes and has provided valuable insights into the history of our planet. The theory of plate tectonics can be traced back to the early 20th century, with the pioneering work of Alfred Wegener and his theory of continental drift. Wegener proposed that the continents were not fixed in place but rather moved over time. His hypothesis was met with skepticism and was not widely accepted until the mid-20th century, when further evidence began to emerge. One of the key pieces of evidence supporting the theory of plate tectonics is the discovery of mid-oceanic ridges. These underwater mountain ranges were found to be the site of volcanic activity and the creation of new oceanic crust. Scientists realized that these ridges were associated with divergent boundaries, where plates move apart from each other. Another important piece of evidence supporting plate tectonics is the existence of deep-sea trenches, such as the Mariana Trench in the western Pacific Ocean. These trenches are formed at convergent boundaries, where one plate is forced beneath another in a process known as subduction. Subduction zones are also associated with volcanic activity and the formation of island arcs. The movement of tectonic plates is driven by convection currents in the mantle, the layer of the Earth beneath the crust. These currents are caused by the transfer of heat from the core to the surface, creating a cycle of rising and sinking material. It is this movement of the mantle that causes the plates to move. There are several types of plate boundaries where tectonic plate movements occur. Convergent boundaries occur when two plates collide, and one subducts beneath the other. Divergent boundaries occur when plates move apart, leading to the upwelling of magma and the creation of new crust. Transform boundaries occur when plates slide past each other horizontally. The interaction of tectonic plates at these boundaries leads to a variety of geological phenomena. Earthquakes are a common occurrence at plate boundaries, as the plates release accumulated stress. The severity of earthquakes can vary depending on the type of boundary and the amount of energy released. Volcanic activity is also associated with plate boundaries, particularly at subduction zones. As one plate is forced beneath another, the subducting plate heats up and releases volatiles, which can trigger volcanic eruptions. Volcanoes can also form at divergent boundaries, where magma from the mantle rises to the surface and solidifies to create new crust. The movement of tectonic plates can also result in the formation of mountain ranges. When two plates collide, the crust is compressed and folded, leading to the formation of fold mountains. The collision of continental plates can also result in the uplift of large blocks of crust, creating block mountains. Continued. Furthermore, plate tectonics plays a crucial role in the distribution of resources and the formation of natural features. The movement of tectonic plates can concentrate valuable minerals in certain